Here we have homework number 2, question number 6. And the problem is stating y prime plus y is equal to f of x. With an IVP, or initial value position, is y of 0 equal to 6. Also state when f of x is equal to 5 between 0 and 10. And it is equal to 1 between or greater or equal to 10. Now, first we got to solve this in 2 steps because it is a piecewise function. So, we're going to state when x is between 0 and 10. So, to do this, we are going to need our integrating factor for it, which we're going to need to find p of x, which is just equal to 1. Therefore, our integrating factor is equal to e to the integral of p of x, which is equal to e to the x, and our q of x, separate these a little bit better, our q of x is going to be equal to 5, because that is our f of x value that we have defined here. So, now we're going, since we have done that, we're going to set up the problem with y times our integrating factor is equal to the integral of our integrating factor times q of x dx. So we're going to plug in our values that we've got. So y times e to the x is equal to the integral of e to the x times 5 dx. Solving the integral, that gives us 5 e to the x plus c. And we're going to label that c1 because we have to do 2 steps, which means there's probably going to be a second constant value that we need. So we have to find the value for c1 now. In order to do so, we're going to, first we're going to divide the e to the x over to both sides to put it in simplest form. So that'll give us e to the 5 plus c1 e to the negative x. Okay, now it's in simplest form, so we're going to solve for the IVP for this problem. And our IVP states y of 0 is equal to 6. Just rewriting that. So we're going to plug in our initial value into this equation, giving us 6 is equal to 5 plus c1 e to the negative 0 power. Now we know from math that e to the 0 power is just 1, so we can cross that out and put a 1 up here. Now that we know that, we can subtract 5 over, and that'll give us 1 is equal to c1. Now we know what our c1 value is. We can take that, plug it back up in here, and that'll give us y is equal to 5 plus 1 e to the negative x. Okay, now that we have solved that, we're going to solve for when x is greater than or equal to 10. We have to go through the same method. Our integrating factor is equal to e to the x, and our q of x value is equal to 1 this time, because it is specified up here that it is 1. So, we're going to put that into our y times the integrating factor integral of integrating factor q of x dx equation, and in doing so, that gives us y times e to the x is equal to the integral of e to the x dx, which when you integrate that just gives you e to the x plus c. 2, because this is going to be a different constant value than this value. These two are very different. Do not get them confused. So, now we have to solve for the IVP, or for C2, but we already used the IVP, and it doesn't even work for this because up here it states that x has to be greater than or equal to 10, which 0 is less than 10, so we can't even use this IVP to solve it. However, we do know that it is a continuous function throughout these two scenarios. So what we can do is take our first value, 5 plus 1 e to the negative x is equal to y of 10, which is equal to 1 plus c2 e to the negative x. And now our x values are 10 because I stated that here in order to solve for c2. So we're going to just rewrite this, go up here and rewrite it to e to the negative 10. Same here, it's going to go e to the negative 10. Now, when we solve for c2, it is going to give us 4e to the 10th power plus 1. Now we have solved for c2. That is our c2 value. And solving for, now that we have all of our values, we can go ahead and plug it back in and get what y is equal to. Y is equal to 5 plus e to the negative x when x is between 0 and 10. Sorry, that it's just supposed to be less than, not equal to. And then y is also equal to 1 plus 4e to the 10th power plus 1 when x is greater than or equal to 10. And this is your solution.